All right, good afternoon. How's everybody doing? Oh, not too bad, not too bad. Got a little bit of the post-lunch. Hope you got a chance to run and get that. Welcome to the Intro to Windows Server 2012 session. Thank you very much for being here. I'm Jeff Woolsey. I'm a program manager in Windows Server and Cloud. I think a lot of people, the feedback I've already heard very quickly, just a few bits of here, is a lot of people seem to be surprised at how much we've already shown and how much looks like is being delivered in Server 2012 R2. Very pleased to hear that. At the same time, I also spoke to a couple of people who said, I'm still trying to wrap my head around what you guys did in 2012, because that was such a huge release, and wow, there's more to even catch up on. So a couple of things I wanted to remind people is, honestly, I wanted to give you a quick reminder of what we did in 2012, because there honestly is so much, and we've had a tremendous amount of momentum around Windows Server 2000, System Center 2012. Here are just a couple of quotes. We could potentially save more than $300,000 annually in software licensing by switching to Hyper-V. Another one from Forrester, an analyst, basically said preconceived notions about Microsoft versus VMware for the virtualization layer need to be re-examined. ESG basically did consolidation testing with Exchange and Hyper-V, and they consolidated as well SQL, OLTP, and Exchange application workloads using Windows Server 2012 Hyper-V with confidence. So there's a lot of work that we've been continuing that momentum, and honestly, we've been seeing even at MMS just a month and a half ago, seeing a tremendous amount of people saying, oh yeah, we're deploying Hyper-V everywhere. You know, yes, we were using the other guys, but that pretty much stuff is sitting stagnant as we're deploying all new Hyper-V clouds everywhere with System Center and Server 2012. So we're extremely excited about that. Thank you. One of the things that you may have heard talked about, and I actually want to be super crisp about this, is how we think about the cloud. So, you know, we talk about, you know, the Cloud OS, and I want to be very specific for this for just a moment here, because very often, a lot of people come in and ask me kind of questions about, well, I'm doing virtualization, so I have cloud, right? So let me be actually very crisp on this for just a moment. When we think about the Microsoft Cloud, our OS vision, it really is about, you can almost think of it as three legs to a stool. And there's really three parts of it. And let's start with the private cloud. Let me be very specific about this, because honestly, some of us that have been working in this, myself, Ben Armstrong, we've been doing virtualization for a long time, and we've seen this happen in real time through our careers. And what I mean by that is, back in the 90s, you could buy servers really cheap. In fact, everyone was buying it, but was it a small startup? We were buying servers left and right. And in fact, into the 2000s, into the aughts, people were buying servers at a very fast clip. Inexpensive, easy to set up, not a problem. And so we had this huge explosion of server purchases, and it's been going on for quite a while. Well, eventually we got into the middle part of the aughts, and all of a sudden, I was still having conversations with folks that said, Jeff, I have all the budget I need to buy as many servers. I have no problem, except I'm in a Chicago high-rise, or I'm in the finance district of New York or something like that, and I simply have no place to put any more servers, and I have no power to power them with. And so virtualization came up as a way to help solve that problem. Instead of 10, 20 servers, let's virtualize those, put them on a single server, and drive more utilization out of that server. So I can take more advantage of it, I still get the isolation and the benefits, and that's great. And there's nothing wrong with that. But that's virtualization for consolidation. Let's be very super clear about that. Okay, I get people say, oh, I'm running VM, so I've got cloud. Well, and here's the difference. When you did that, when we made that transition and started using virtualization for consolidation, the management paradigm never changed. What I mean by that is people still logged into a VM and treated it like a physical machine. They made tweaks to it. Oh, I need to give it some more storage, give it some more memory. And they still managed it like its own entity. In cloud, I want to be able to say, you know what? I want to deploy a standard set of resources. Okay? And it's not necessarily a VM anymore. Maybe it's a 3-tier workload. I've got multiple tiers, and I deploy it in small, medium, and large. Think of them as T-shirt sizes. And I want to be able to give an application or a service a set of compute, a set of memory, a set of storage, and let it go. And guess what? If it needs more, then it just elastically grows. And when it's done, it can elastically shrink. Cloud is requestable. Cloud is chargeable. Cloud is available. Cloud is usage-based. That's how we think about it. Okay, again, there's nothing wrong with virtualization. You want to do that, that's old hat. We've been doing that for a while. Happy to do that. But that is very much different than cloud. The other area I've seen a huge issue over the last 10 years is everyone is so focused on the hypervisor, they totally forget about management. This just happens every year, every year. You know, people tell me, oh yeah, you know, I'm running all these things and I'm running X amount of VMs. And then I ask them very simple questions that they cannot answer. How many VMs do you have in your infrastructure? You know, people will come into our executive briefing center. I'll ask that very simple question. And the CTO will confidently say, we have about 800 VMs. And the guy sitting next to him who's running the director of IT says, no, it's actually more around 2,500 VMs. And the guy who's sitting down the other end of the table says, it's actually more like, 25, 2 or 3 times more than that. They're not even close on that. So if you can't even tell me how many VMs you're running, how do I know that you're running all of your applications and workloads and you're meeting all of your health requirements? Because at the end of the day, I don't care if I'm running SQL on a physical server or in a VM. I care that SQL is running well. So when we think about cloud especially, it's about management, it's about Windows Server and System Center. Now private cloud is about control, all right? As part of the outgrowth of virtualization, it's like, you know what, I'm building this and I'm running this on my premises. And there's nothing wrong with that. I've spoken to people in Canada and Australia and Europe, and they say, you know what, Jeff, I have some workloads that no matter how cool you tell me running in a service provider in Azure is, I've got a workload that has to run in a Canadian data center on Canadian soil by a Canadian citizen. So you're going to try and convince me to move it elsewhere? No, I'm not. I'm absolutely not. Because you know what, this is not a technical discussion. This is a business reason. You need to run it on your premises? Fantastic. Let's give you the best way to do that. And that's with Windows Server and System Center. However, at the same time, we've also made these huge investments in the public cloud. Because guess what? We know this is where a lot of you want to go. But you want that flexibility to do it on your terms. And so when we think public cloud, we have platform as a service, we have software as a service, and we have true infrastructure as a service with Azure Virtual Machines. Now, if you take a look at that, that's pretty awesome. That's pretty comprehensive. But then also don't forget, we also have service providers. And again, we think of this as 3 tiers to 3 legs to a stool. The private cloud is about control. The public cloud is about scale, while service providers are about reach and customization. A service provider you may be working with, you may already have terms you've already been working with, and maybe you want to say, you know what, I have a specific workload, I want to run a specific set of servers in a specific rack in the service provider's data center. That's something we're not going to be able to deliver in Azure, and you know what? We absolutely want you to be able to go to service providers and get that level of customization. So we think of this all together and holistically as one consistent platform. And this is very important to us because this is actually very different than anybody else. You talk to VMware, they're going to tell you, you know what, cloud is that thing running in the bottom corner. It's that private thing. Or they're working on some sort of a hybridity thing that no one really understands yet. If you talk to Amazon, they'll tell you, no, cloud is actually running VMs up on Amazon. That's that infrastructure as a service thing. If you talk to Salesforce.com, they'll tell you something different. They'll say, no, neither of those are cloud. Cloud is actually running on Salesforce.com. It's SaaS. We fundamentally disagree with all of that. Cloud is all of those things. And we want you to be able to consume those based on your terms. So when we think about it, it's about providing an excellent development platform. It's about providing an excellent management platform that's consistent across all of these. It's about having that data platform, whether that's SQL Server you're running on premises or SQL Server running up on Azure. Identity. Identity is so key. Active Directory is what powers so many companies, so many businesses, so many enterprises, and guess what? Active Directory is already there waiting for you in Azure. So again, that consistency. And finally, virtualization. I love virtualization. It's what I've been working on, seems like, 15 plus years, love it. But it's not the end state. It's a key part of this. And guess what? For us, that means Hyper-V is running on private cloud, Hyper-V is running in service providers, and guess what? Hyper-V is what powers Azure. Full stop. Show me a public cloud from the other guys that's running at our scale. Windows Server 2012 is what powers Windows Azure. It's the same bits you're getting. You're getting all of the advantages we've learned by powering Azure, by running it on our premises, and then we build that into Azure, we build that into Windows Server, and it's this awesome virtuous cycle. So everybody gets the benefits from our cloud learnings. So in Server 2012, we delivered a lot. One of those things was scale and performance. You told us quite simply, you want to be able to virtualize any workload. That's exactly what we did, with support for up to 320 logical processors. That's a big, big server. Just to put that in context, that's a 16-socket server. Each socket has 10 cores, and then you enable symmetric multi-threading. That's how you get to 320. On top of that, we support up to 4 terabytes of physical memory. Just to put that in context, I believe that's about $500,000 just for the memory. That's not even the server or the storage. That's a big, big box. Okay? We support up to 64 virtual processors per VM. And I want to point out, this is not something you need to go buy some Enterprise Super Special Plus edition. You get 64 virtual processors with Windows Server 2012 Standard. You get it with Windows Server 2012 Data Center. In fact, I give this away with Microsoft Hyper-V Server, our free hypervisor. 64 virtual procs, because we think about this very differently than the other guys. The other guys are about a la carte. We're all about providing you the best cloud infrastructure. We support up to 64 terabytes per virtual disk. That's not a typo. That's 32 times anybody else in the industry, because we know big data is here. So we want to make sure our platform supports that. Up to 64 nodes and 8,000 virtual machines in a cluster. One of the most common questions I get about that one is, number one, why? Well, I'll tell you why. Enterprises and cloud service providers. Both of those guys said very loudly and very clearly, we want really big scale-out clusters. And guess what? The moment we shipped, we had handfuls of customers that were deploying RTM bits on 64 nodes and 8,000 VMs. The question I always get, number two, is, Jeff, do I have to have 64 nodes to get to 8,000 VMs? No, you actually don't. We support up to 1,024 VMs per host. So technically, if you wanted, you could do an 8-node cluster with 8,000 VMs. I would never in a million years recommend that, because your fault domain is way too high. But I will tell you that at MMS just a month and a half ago, we ran a 32-node cluster and ran over 8,000 VMs, and it ran flawlessly. So, you know, it depends on the type of hardware. The point is, you get to, you can adjust both variables. And in fact, the 64 nodes is actually really important, because when you get to 8,000 VMs total, that's 125 VMs per node. Okay, so there's a point where there's so many VMs that you need to raise the node count to be able to handle that type of failover. In terms of performance, one thing I want to be very crystal clear about. If you're running Dynamics, if you're running Exchange, if you're running SharePoint, if you're running SQL Server, if you're running Link, the absolute best way is on Microsoft Hyper-V managed by Microsoft System Center. Performance is one part of it, but it's much more than that. It's test. It's support, it's validation, it's optimization, it's performance, it's optimization, it's test, it's test, it's test, it's test, it's test. Let me say that one more time, it's test. We test every one of our workloads. We run all of our workloads in Azure, internally at Microsoft. All of our application workloads are all testing on Hyper-V every single day. Within the Windows Server division alone, we create 25,000 Hyper-VMs a day. A day to run automated tests on every build of Windows Server. We do unit tests for all of them. Everything that passes, we delete those VMs and go on to the next day. If VMs have failures, we pull those out, we send those over to test dev. They can take a look, determine the problem, determine if a fix is required. That is an incredible amount of automation and testing we do every day. You will only find that with Hyper-V on our applications. We've done third-party testing, SQL, testing on Hyper-V. You're seeing fantastic linear scalable performance. You can see as we go all the way up to 64 virtual procs, you're seeing nearly perfect linear scalability in the virtual machine. Absolutely fantastic. We also did performance testing with Exchange. Now, one thing I want to be very clear about up front, this is not a deployment recommendation. This is 48,000 mailboxes on a single server. Exchange is designed for scale out. That was not the point of the test. The point of the test was to see just how many mailboxes we could pile up on here, as well as meet Exchange's performance requirements, which means you've got to have less than a 20 millisecond read response time for Exchange. And we hit it without a problem. So you talk performance and scale. We have further ones coming on with Dynamics as well. Another area was storage performance. While we delivered 64 virtual procs and a terabyte of memory in a virtual machine, it doesn't matter if I can't keep all of those processors and memory busy. So we delivered outstanding performance, over 1 million IOPS out of a single virtual machine. Let me say that one more time. 1 million IOPS from a single virtual machine. To get that level of performance just a few years ago, you'd have to have clusters of servers. We're now doing it out of VMs. That's how powerful this is. And it's not that in the past we were a slouch. We could deliver over 250,000 IOPS out of 2008 R2, but we absolutely crushed it in 2012. So we're feeling very, very good. In fact, we know that we can virtualize over 99% of the world's SQL Server. High performance storage. Live storage migration introduced in 2012. We also introduced the new VHDX format, giving us up to 64 terabytes per disk. I also want to point out that auto aligns with SANs. So there's no sort of alignment issues. Using VHDX, it automatically does the right thing. Native 4K disk support, virtual fiber channel support, offloaded data transfer support, as well as automatic trim and unmap. Here's a real simple one for you. Anybody out there own a SAN? Anybody? Fantastic. Here's something you need to walk away with and understand and internalize. Very important. If you own a SAN, Server 2012 is an absolute no-brainer. It's like literally, if you haven't installed it, what are you waiting for? Because with 2012 and 2012 R2, we have these capabilities that allow us to integrate and leverage SAN capabilities. Offloaded data transfer is a perfect example, where we actually offload capabilities and we can perform massive operations at a fraction of the speed by taking advantage of your SAN. Another one of these is automatic trim and unmap. Let me give you a perfect example. You're running a virtual machine. This virtual machine has 60 gigabytes of storage assigned to it. You delete a 20 gigabyte file inside the VM. What happens to your SAN storage? Answer, nothing. Even though you deleted 20 gigabytes out of there, your SAN doesn't know. So it still has a 60 gigabyte file. With automatic trim and unmap, we actually Hyper-V and the VM notifies the file system notifies the SAN that the 20 gigabyte file was deleted, and guess what? Your SAN can automatically reclaim it. No other hypervisor provides automatic trim and unmap. That's all built into 2012. If you know storage, you know that's gold right there. I just gave you automatic reclamation of space from a virtual machine. So, in addition, we also made huge investments in the file server, the CA file server. And one quick, and as well as rich networking in the box. Network virtualization, the open extensible switch, network quas, network metering, SRIOV, just rich capabilities, whether it's storage, whether it's networking. And then finally, of course, VM mobility. In 2012, we were the first hypervisor to offer shared nothing live migration, long considered the holy grail of virtual machines, to be able to live migrate VMs from server to server with nothing but a network connection. No shared storage. Literally, just live migrate and it all just works. In fact, one of the other cool things about it was the fact that we provided concurrent live migration. This is something that Brad really wanted to show in the keynote. We just didn't have enough time because we were running short on time. But this is 2012, folks. This is Server 2012 live migrating 40 VMs simultaneously. That's right, 40 VMs simultaneously. In 2012, we provide unlimited concurrent live migration, limited only by the hardware you want to bring to the party. If this is gigabit Ethernet, yeah, maybe I can do 2, maybe I can do 4. If this is 10 gigabit Ethernet, maybe I can do 10 or 20. If this is dual team 10 gigabit, maybe I can do 40, which is what you're seeing right here. If this is quad team 10 gigabit, sky's the limit. But again, all these capabilities are part of 2012. So with that in mind, and the video's just finishing right there, now we're off to 2012 R2. And man, we got a lot to show you here. So we made some major investments and some themes that we're thinking about for Windows Server and System Center 2012 R2. Number one, we are going to continue to focus on a data center without boundaries. Again, this goes back to our core cloud OS vision. Our North Star is exactly those 3 clouds. Just to be very clear, that's what everyone is working on at Microsoft. Whether you're in client, whether you're in server, whether you're in System Center, whether you're in Azure, that is our North Star. Everything is plugging into that. And to provide that from server and System Center, we need to provide a data center without boundaries. Cloud innovation literally everywhere. That's Azure, that's System Center, that's our apps. We think about things very much cloud first. Because we know you want the flexibility to run your applications, to run your workloads wherever it makes sense. and based on your requirements, whether it's HA, whether it's cost, whether it's location, whether it's data sovereignty. There's a whole bunch of decisions you have to consider, but we want to give you the best solution every time. Dynamic application delivery. I want to be able to get my apps wherever, whenever, on whatever device. Maybe it's a Surface, maybe it's an iPad, maybe it's iOS, maybe it's Android, I don't know. But I want to be able to give you that application. I want to be able to manage those devices. I want to be able to give you, I want to be able to provide policy on those devices, and I want to be able to do this whenever and wherever you are. A flexible and consistent application platform. Like I said, whether you're running on-premises, in a service provider, or in Azure, that experience should be the same. That application should be the same. But that application should also be consistent. It should be elastic. Again, think differently. And of course, we want to enable people-centric IT. Whether that's, you know what, I need to deploy a whole bunch of virtual desktops, I need to use, or I want to run a remote app, or I want whatever app available to me on whatever device. So I'm going to be focusing on, the first few here. Data center without boundaries. Multi-tenant cloud infrastructure, standardized data center resource management, enterprise-class virtualization, robust open source support, best-in-class performance and scale for Microsoft workloads. So with that, let's talk about pulling ahead in virtualization. I already showed you the work we did in 2012, and I'll be honest with you. When we sat down and started looking at 2012 R2, it's like, wow, we nailed a ton of this in 2012. What are the problems we need to solve this time? Very interesting. We sat down, and again, we appreciate all of your feedback. And please, when we're done, come up, tell us, what else do we need to do? How do we need to make your life better? Because that's exactly what guides and governs us for the next releases. You told us you want to reduce complexity, cost, and downtime. One of the things that I've heard over and over again is people love Hyper-V Replica. Why? Because it is so easy. Before Replica, DR has been so painful, it's been so difficult, it's been so expensive. Now it's literally right-click on a VM, walk through a wizard, and I'm now replicating to another site. Wow, we love that. Keep doing things like that. Make ease deployment and support lifecycle of workloads. Provide flexible virtualization platform for maximum agility. And we've responded with a variety of things. Cross-version live migration. I want to be able to upgrade my cloud infrastructure. I want to, if I've deployed already Windows Server 2012 and System Center 2012, I literally want to be able to drag and drop VMs onto 2012 R2, and it just works. And guess what? Now I take advantage of all that cool new storage tiering and storage deduplication, and all those key new features just magically light up because I live migrated the VMs. We're going to make that really easy for you. Online VHDX resize. Automatic VM activation. This is actually something really cool for cloud service providers. We can make it really easy now. If you're running Windows Server 2012 R2 Data Center Edition and Hyper-V, guess what? You put a Windows Server 2012 R2 VM on there, and we will automatically activate the VM for you. You don't even have to activate the VMs anymore because we'll do it automatically for you. So it's a real subtle thing, but for a cloud service provider, this is gold. We just made your life really, really easy on that one. Live VM export and cloning, remote access via VM bus, all very powerful features. With remote access via VM bus, I can now get console access to virtual machines without actual network connectivity into the VM. Live migration compression, live migration with RDMA. You saw me demo these earlier in the keynote today. Spectacular performance. Just jaw-droppingly awesome performance. And by the way, we're still very early on. We're going to be tuning and tweaking this quite a bit more. And I bet you that performance is going to get even better. And then more robust Linux support, which actually leads perfectly into my first demonstrator. Please give a hand to Ben Armstrong. Ben?
So, hello, Jeff. Thanks for the introduction.
Hey. Thanks, Ben. Great to have you.
So Jeff asked me to come here today and give a brief demo of some of the new stuff that's coming in Hyper-V. Now, I'll be completely honest, I'm just doing a teaser for my session later on today. I have a session on what's new in Hyper-V in 2012 R2, and we're going to be going through all the features. I just wanted to pull out a couple of interesting ones to show here as part of this session. So the first thing I'm going to do is I'm going to bring up this virtual machine here. we're going to do a little bit of role play here.
Okay.
So Jeff, you're going to be a hoster.
Absolutely.
And I've bought a virtual machine from you.
Fantastic.
And I'm happily using my virtual machine. And I go ahead and I kick off a big database workload inside the virtual machine because I got some numbers to crunch. And so this is going to come up. And immediately, look at that. I'm getting great performance. But Jeff, what's happening to you right now?
Dude, you're crushing all of my IOPS performance.
And in fact, I think right now your phone...
I'm actually very upset right now.
Yeah, your phone is going off the hook because you've got other people calling you and saying...
What happened to my other performance? There seems my performance for my other customers on this host has gone way down.
Exactly. Now, I've actually talked to customers who've been in my situation today. Do you want to know what their hoster did to them?
What?
They turned off their VM.
Oh.
Can you imagine that? You know, you paid for this VM, you start a workload, you don't know that's disruptive to the environment. And next thing you know, bam, your VM's turned off and you've got a nasty email from your hoster. So thankfully, no one has to be nasty anymore with 2012 R2. What we can do is I can come in here and just find this virtual machine. I've just moved it to the side so we can keep an eye on this. And I am just going to go in and cap this.
Yes, that's what I want to do.
And immediately what we're going to see, the I/O just dropped down. Now, you're happy.
I'm thrilled.
Because people are no longer complaining. I'm happy because my workload's still running. Sure, it's going to take longer, but hey, it's a big database workload. I wasn't expecting, immediate response.
Well, actually, I'm really happy because I'm selling you bronze level service at 100 IOPS. But now, you know what? I can upsell you to silver level service for 250 IOPS, and I can make a little more money.
Exactly, and we can do this all on the fly with zero downtime. So I think that's pretty cool. We'll come back here. I'm going to close this down so we can shift over to the next demo. I have to turn that off because it really does drain all the I/O on the system. So the next thing I want to show you, and you mentioned this, is I don't know how many people in this room are aware, but at Microsoft we actually have a team that's dedicated to working on our Linux support story. So I have a Linux virtual machine here. It's running SUSE Enterprise Linux. Let me just shuffle this around a bit. And there are a couple of things I want to show you that are coming out with 2012 R2. The first thing is that we are now doing full dynamic memory support for Linux. This is not some sort of halfway thing. It is the full hot add and remove, just like we have on Windows. So I've brought up this little panel here. You can see that this Linux virtual machine has a startup memory of 1 gig. We've booted it up, and it's boiled down a little. It's down at 800 megs. So there we see that ballooning's already working. But I'm going to come in here, go to command prompt. I'm just going to run a little app that we put together that is just going to use 150 meg of memory at a time. And what you're going to see is as we use the memory is getting hot added to the Linux virtual machine, all in response to the guest workload.
So full-on dynamic memory for Linux.
This
awesome.
is exactly what we deliver for Windows. Exact same capability for Linux.
Awesome, Ben.
So the other thing I want to demo for Linux is, this is one of those features where it's not particularly sexy. You don't see people getting, up on stage about this too often.
I don't think people use Linux for sexy.
But this is really important. So what I'm actually going to do is I'm going to back up this Linux VM. Now, if you've had any experience with backup and Hyper-V, you'll know we have the VSS-based backup for our Windows virtual machines, where we allow you to back up those virtual machines through the host operating system with zero downtime. It's a great feature. But in the past, we haven't supported this for Linux.
That's because Linux doesn't have VSS.
Exactly. So in the past, when you try to back up a Linux virtual machine, what we'd actually do is we'd have to put the virtual machine into a safe state in order to make backup work. Well, what I'm going to do here, I'm going to start this backup. I'm going to bring the Linux virtual machine. So we'll see that this actually runs throughout the whole process. Now, you're right, Jeff. Linux doesn't have the VSS infrastructure. So how are we making this work? Well, as I mentioned, we have a development team at Microsoft that's dedicated to working on our Linux support. They've worked very hard to develop guest component for us that will actually do a file system freeze so that we get a file consistent backup of this Linux virtual machine with zero downtime.
Awesome.
So what you'll see, I'm just going to initiate this backup. It's going to call into Hyper-V in a moment, do the file system freeze, and by the time we start to see data being copied, then it's already happened. And the key thing is, here we go, data's copying. So we've already taken a snapshot of this virtual machine running the whole time.
Fantastic.
So one of the things I would like to point out is, if you have a bunch of Linux servers in your environment, you should virtualize them just to get this backup solution. This is a fantastic, reliable, simple backup solution for Linux. So I'm going to get rid of that. And there's one more thing that I want to show you, and that is this virtual machine here. I'm going to bring it up, and you can immediately see this is a virtual machine that I have set up as a cluster. I have two virtual machines. They're running on different physical boxes. I'm just connected to one here. I've got a file server row running on here, and I've got a couple of disks. But I do not have any iSCSI or fiber channel in my environment. This is...
Hold it. You said you're clustering two VMs.
Yep.
But you don't have iSCSI or fiber channel.
That is correct.
So how are you doing shared storage into the VM, guest cluster?
So here I'm using our shared VHDX functionality. So I have two virtual machines, I have VHDX files, and I have them configured for sharing. So a key thing to point out here is that this isn't some dev test thing. Those VHDX files are themselves running on a highly available SMB server running 2012 R2. And in fact, we use that SMB server to do the shared file access semantics. So in my lab, I have just the good old collection of SAS disks with a shared chassis. I've got storage spaces on top of that. I've got my scale-out file server on top of that. And then because of that, I'm able to do enterprise-grade clustering inside a virtual machine without any new hardware.
So within the virtual machine, what does the shared storage look like?
So this is interesting. It actually shows up as a SAS-connected disk. So I can go in there, it shows up as a SAS disk, even though it's VHDX. I ran full cluster validation on this. It did all the disk tests. Everything came back just beautifully. So this is really powerful because now I can provide guest clusters on exactly the same infrastructure that I'm providing standalone virtual machines today. No new infrastructure needed.
Awesome. Awesome. Thank you. Anything else?
No, so that's all I want to show.
Thank you so much, Ben. So shared VHDX, that's an incredibly powerful new capability. And in fact, it's extremely powerful both for enterprises, as you heard, for test dev, but also for production. In fact, it's ready for production, but more importantly, for cloud service providers. Because one thing that's very interesting is that separation between the folks running the cloud infrastructure as well as customers on top. And this is one of the interesting differences between a cloud service provider and an enterprise. In an enterprise, guest clustering could be just fine. Okay? As the infrastructure guy running my enterprise, and Ben says he wants to do guest clustering, that's not a problem because we're all one big happy family. So I can expose an iSCSI or a fiber channel onto them. In a cloud service provider, that's not happening in a million years. In a cloud service provider, I want to keep that separation between the physical hardware and the infrastructure below and the virtualized resources on top. So now a cloud service provider can actually provide you guest clustering, provide you high availability, and do it with a shared VHDX, shared virtual hard disk. So this solves some really difficult problems, again, in Server 2012 R2. Awesome. So, by the way, I do want to point out, I'm going to show Ben a little love here. Yes, MDB330, there's a session a little bit later. Do check it out. He'll be going super in-depth, even more, on Hyper-V. So, cloud innovation everywhere. So, again, we've got a lot of stuff new in 2012 R2, so I'm only going to be able to skim a whole bunch of things off the top. But this next session is about, number one, storage. Talked about it a lot. You know why? Because it's really important. It's the most expensive thing in your infrastructure. Every so often, someone will come to me and say, hey, I just realized, I just actually looked at the bill for how much I paid for my storage last year. And I say, yeah, and it was like by far over half, approaching maybe 60% of my cloud, of my data center infrastructure is storage. Yeah, we've known that. It's why Azure it's why Azure uses just standard old direct attached storage. Okay, we don't use SANs. I get that question all the time. What SANs does Azure use? It doesn't. Doesn't scale, doesn't meet the performance, doesn't meet the cost effectiveness we need. You want to do cloud scale, you got to keep it cheap and you got to keep it simple. Okay, we're all about doing both of those things. We want to give you really fast performance, we want to give you great performance, we want to give you resiliency, but we want to do it using mainstream hardware. So we want to be able to lower those costs for storage. And it's not capacity. Capacity hasn't been my problem for quite a while. I mean, I can buy, 2 terabyte, 3, 4 terabyte disks now. It's I/O that's crazy expensive. It's that cost per IOP that has been crazy expensive, and it's been up there for quite a while. So we are very laser focused on driving down cost per IOP as well as gigabyte as well. Software-defined networking. We made huge investments in Server 2012 around network virtualization, as well as providing that seamless infrastructure to Azure. Automated protection, simplified identity. Again, I'm using Active Directory on premises. Guess what? Azure Active Directory is already there, ready to be federated. So one thing I wanted to do was take a moment to really quickly talk about storage. Because I talked a little bit about spaces in the keynote, but one of the things I've realized over the last few months talking with people is they're not exactly sure what spaces is. So let me explain to you very quickly. We're going to take a quick tour through storage. So what is a storage appliance? You go out and buy some sort of SAN. What is it? Have you ever actually opened it up and looked inside? What's in there? What you'll find is it's got some x86, x64 processors. It's got some memory. It's got some network adapters. It's got some storage HBAs. Huh, that sounds kind of familiar. Sounds like a server to me. Okay, well, let's take a look further. So if you look inside one of those storage appliances, one of those storage heads, what do you see? Like literally what's in there? Well, you'll see that if you carved it in the half and said the back half of it, that's where you have these HBAs. And those plug into your physical disks, usually SAS. Okay? So you got these multiple HBAs, they plug into your disks, and this allows you to basically pool those disks, present LUNs, give you mirror parity, etc. So that's what the back half of a storage appliance does. What does the front half do? The front half presents interfaces like iSCSI, fiber channel over Ethernet, NFS and SMB. Of course, when you buy one of these, they actually don't sell you one. They sell you two because they want this to be a scale-out storage appliance. It's clustered, essentially. And you deploy at least two, so that way, if one of them goes down, the other one continues right along. Okay? And then your servers plug right into that. Can be Ethernet, can be gigabit, can be 10 gigabit, could be fiber channel, could be 1, 2, 4, 8, or some of the newer ones have 16. That's essentially what a storage appliance is. So, what are we delivering in 2012 and 2012 R2? Wow, doesn't that look familiar? Spaces is the back part. That is what Spaces is. I'm being super crisp about this because sometimes I get a lot of questions, people asking me these interesting questions about spaces. Can I take a space and have it running on one site and a space running on another site? That tells me that we're not explaining spaces very well. So spaces is what allows us to take those physical disks, pool them, create LUNs, mirror parity, 1, 2, 3-way mirroring, and now we introduce tiering as well into spaces. What's the front end? The front end is the file server. That's what presents iSCSI, NFS, SMB. And by the way, SMB3 is what rocks. And by the way, you cluster the two. And if you want to run 3, 4, all the way up to 8, guess what? We can create a massive scale-out file server. So that is what the file server in Spaces is all about. And by the way, if you want to know more about that, check out B333, Software-Defined Storage, with Windows Server 2012 R2 and System Center 2012 R2. So that's what it looks like. Hyper-V and the scale-out file server. You've got a bunch of Hyper-V hosts communicating via SMB3 to your scale-out file server, where the scale-out file server is backed by Spaces using, and of course, block storage, and of course now with tiering. So, familiar enterprise capabilities. Again, here's where we've made some huge advancements in R2. So, storage tiering, data duplication, RAID resiliency groups, pooling of disk, HA. Yes, you see that with traditional storage. You also see persistent write-back cache, copy offload, and snapshots. Well, look at what we're delivering in the file server. Tiering. That's what's brand new in Server 2012 R2. That's what allows us to deliver lightning-fast performance and take advantage of SSD. Because SSD is now mainstream. It's awesome. I've been waiting for SSD like half my life. It's fantastic. It's what delivers spectacular I/O performance. Data deduplication. It's severely enhanced in R2. Like I showed you this morning, I'm doing data deduplication with running virtual machines now. Flexible resiliency options. For example, we now support three-way mirrors, pooling of disks, HA, persistent write-back cache, also new in 2012 R2, SMB copy offload snapshots. So you can see a very rich capabilities that we're offering in storage. And again, tiering, a cornerstone new capability in Server 2012 R2. So with that, I'd like to invite Matt McSpear up, because one of the things I want to show you is now that we've got these capabilities in Windows Server, how do you deploy these? Is this difficult? Is this hard? If I want to deploy these, say, from scratch, how could I do it? Matt?
It's extremely difficult.
Oh, my goodness.
No, I'm kidding. So, am I on?
Are you on?
I am now, I think. Yes, can you hear me? Yes, excellent. So, as Jeff said, we want to help simplify things like deployment of resilient storage for high performance, for at low cost using commodity hardware. And what we've got on the screen here is a view of Virtual Machine Manager 2012 R2, and it's going to allow me to provision a new clustered file server. So have that picture in your mind that Jeff showed of the Hyper-V host connected via SMB to our clustered file servers with shared JBOD at the back end. I'm going to show you how easy it is in VMM to build that. So I'm going to go to File Servers, and I'm going to create a new file server cluster. And as Jeff said, this is literally going to be a couple of Windows Server nodes, of which we can expand out in the future, connected to some shared JBOD. So first things first, I'll give it a name, and I'll give it a file server name as well. And this is just to identify it in the network. We'll go next, and now I've got a choice. Do I take advantage of something that's already been configured for me? So a couple of Windows Server 2012 R2 machines that are already running, and I can configure the file services role and feature that I need on top of that. So I can make use of something that exists. Or alternatively, I've just got a delivery, we've racked some new servers into our rack, we've connected it up to our shared JBOD. How do I configure that? Well, I can do that from here as well. So I can provision bare metal machines with a file server profile that's defined in VMM. And that file server profile effectively says, okay, we're going to push a virtual disk down to that physical server, boot from VHD, so boot from the virtual disk, and when it comes up, we'll apply the configuration items inside that profile onto that physical machine. So we can consistently roll out new file servers in a standardized manner, which is very, very important. It helps us keep control, and it keeps things simple. So we'll go that way, and to do that successfully, we need to interrogate and communicate with the baseboard management controller. So I've got the credentials and the run as account that I need to do that, and I can choose my particular protocol that I'm going to use to communicate, and the port that's necessary in my environment. So we'll go next, and it's going to go out and it's going to go and discover that particular environment, or those particular hosts. I'll copy, paste. There we go. We'll go next. It's going to go out, it's going to discover, and it's found very quickly those two physical servers. So I can tick those boxes. Remember, these servers they're off at the moment, but the baseboard management controller still allows us to communicate. Now I'm going to skip what we call deep discovery, and that's going to save me a bit of time for demonstration, but this is beneficial because what this will do is this will wake the server up, boot it into a WinPE, a customized WinPE operating system that VMM has deployed, capture metrics about this server, such as CPU numbers, cores, information about the disks and the NICs, and it will bring it into this wizard to help me customize the process that little bit more granularly. So I'm going to just skip over that for now, give the machines a name, and we're pretty much good to go. I can view the PowerShell script that's going to go behind the scenes to perform this task, so I can reuse and standardize utilizing that as well. But that's essentially it. If I click Finish, it's going to go ahead and it's going to deploy those virtual disks to those hosts, bring them up, configure them, and we're going to have a working file server cluster just like that. But that's only part of the story, because we've still got to manage the actual capacity and the storage. So if I look at one I created earlier, if I look at the properties of this particular file server or clustered file server, it's 2 nodes, like the one we were just going to configure, and I can easily add additional nodes just by bringing them in through VMM. So it allows me to scale out from that standpoint. But what about the capacity? What about my disk space? Well, if I manage my pools that Jeff referenced earlier, here I've got one already created. There's 6 disks that are already in this pool. It's okay, it's healthy for now. But if I need to expand, I'll simply edit. I'll tick the disks that are important to me to add, to expand, and I'll click OK, and that will expand on the fly. And finally, very important, this thin provisioning alert. If I'm thin provisioning my spaces, which is a feature as Jeff called out, I want to make sure that I'm not thin provisioning so much and as capacity grows that I use more than I've actually physically got. So we've got the alert system in place in VMM, and if you're using Operations Manager with the management pack for VMM, you'll get visibility in there as well. So that's very, very important for proactive monitoring of your storage infrastructure. So the final area, we've configured the clustered file server, we've got our pool and our capacity, we need to make it available via SMB to our hosts. And to do that, we simply create a file share on the particular clustered file server that we're interested in. So I'll call this one Mat Share. The classification within that pool, and I'll give it a capacity of 20 gig. And as simple as that, I can create this new share on that particular scale-out file server, so it's resilient because it's on those cluster nodes. And within a few minutes, I can very easily start to assign that to a particular set of Hyper-V hosts. So it's going to take care, VMM is going to take care of all of the necessary ACLing to provide and present that share to the appropriate host. Now, that may take a few minutes to come through, so it may not appear in my wizard, in which case, no. So I would just select this one, OK, apply, and it will be then ACLed and presented. That is simplicity.
Awesome. Really cool. Awesome. Thank you, Matt.
Thanks, guys.
So think about what you just saw there. First of all, don't forget that System Center Virtual Machine Manager can already deploy Hyper-V and already do a bare metal deployment for all of your compute nodes. It already can do that. Now with 2012 R2, what we're saying is, look, from a storage perspective, it can, from bare metal, do that complete scale-out file server deployment. He never touched a physical box. It was all done remotely. Think about this now. You can literally roll in a rack of servers and say, yeah, I'm going to come over to this one console. I'm going to provision my compute nodes. I'm going to provision my scale-out file server. I can configure my tiering, my pools, all of these things here. All of this remotely from System Center VMM. Powerful integration with Windows Server. So one thing I wanted to mention was, Ben mentioned that, just showed this guest clustering, but I actually wanted to set up the problem just to be very clear about the problem we're solving here, which is in a cloud service provider model, this is how that world looks. You've got infrastructure admins they're basically running at the very bottom here. You've got cloud service provider infrastructure. If I'm a hoster, this is what I care about. I'm focused on this bottom layer. Okay, everything below the red line. Okay, that's how I make my money. I make sure that I gave you great compute, great storage, great networking, and you know what? I want to be able to upgrade you. Maybe I get some new servers, maybe I get in some new storage, maybe I get some new things, and I want to make those changes without you knowing about it. You're all my customers, and you're running here. You're running above the red line, okay? And that line is really, really important because VMs and services are provisioned, but physical resources are opaque. You don't know what server you're running on. Okay, I don't know what type of server. I don't know what type of storage. All I know is I've been given virtual storage. I can see I have virtual storage, and I have some amount of capacity, and I have some amount of processor and memory, but I don't see exactly what it is. You want to maintain that clear separation. Well, for guest clustering, though, is problematic for a cloud service provider because it requires that you pierce this hole. Because what you have to do is you have to present a LUN. I have to make a fiber channel LUN or an iSCSI LUN available to the virtual machine to do guest clustering. And what happens is, quite simply, cloud service providers don't do it. They say, sorry, Charlie, that's not happening. I'm maintaining that line. So what ends up happening is nobody's happy. The customer who has been running a guest cluster perhaps on their premises and wants to move it to the cloud can't. Because the cloud service provider says, sorry, I'm not doing that. The cloud service provider is unhappy because he wants to offer this as a service, but he's not willing to pierce that boundary. So with guest clustering and shared VHDX, everybody's happy. Because with introducing shared VHDX, essentially we're creating virtual disks that can be shared without presenting the real LUNs to tenants. And it looks just like this. So the virtual disk lives on top. It's above the red line. Customers are happy. They get their guest clustering. The cloud service provider's happy because he can provide it as a service, and most likely it's an upsell. You know what, I'm going to charge you 40% more. Okay. I'm used to paying more for HA, and I'm willing to pay more for HA, but I have to be able to do it because there's no way I'm moving this workload to the cloud if I can't get guest clustering. That's why this is such an important feature. And in fact, again, this is something even more important for cloud service providers than enterprises. So, software-defined networking. I want to go back to this one for just a second. It looks very much like the slide I presented earlier talking about our three legs of a stool. But here's the thing, I made a little changes here because I want to point out something very important about software-defined networking. For the last 18, 24 months, the industry's been talking about software-defined networking. For the last 18 to 24 months, we've been saying all the wrong things. Like literally someone says, hey, why software-defined networking? Oh, because it gets rid of the VLAN scalability problem and it's NVGRE and it's blah, 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 and it's blah, blah. No, wrong. The real question is, why software-defined networking? Here's the real answer. Here's the simple answer. This is where we live today. You've got private clouds, you've got service providers, and you've got the public cloud. With software-defined networking, it makes it possible for me to move and provide services hybrid to public cloud, to service providers, and to move them from any one of those. That is why you want software-defined networking. So when the next time the guy says, oh, it's the VLAN problem, because most of you are going, what is the VLAN problem? What is this problem everyone keeps talking about? That's not the reason. The reason is agility. If you want to move to the cloud, guess what? Network virtualization is actually, in my opinion, I don't know how you're going to do it without it. It's going to be a disaster without it. You're going to have to change IP addresses, you're going to have to re-IP workloads, and it's going to prevent you from moving in the first place. Software-defined networking is about providing this seamless experience. So I can take workloads, run them on my private cloud, run them in Azure, move them to a service provider, wherever it makes business sense. So why network virtualization? It's about agility. It's about easing management. What we're doing is we're separating the control plane and the data plane. And it's centralizing management of the control plane. It's about solving really tough problems like live migration across subnets, which without network virtualization is not possible. By definition, you traverse a subnet, you've just dropped the connection, there's no live migration. Network virtualization, not a problem. It does break the VLAN scalability limits. For large enterprises and cloud service providers, this is actually a very real problem. For a lot of people, it isn't. But if you're a large enterprise or a cloud service provider, you know what I'm talking about. Quite simply, there's 4,096 VLANs into the VLAN spec. Most switches top out at about 1,000. I've talked to many cloud service providers that have hundreds of VLANs. I was in Australia last year, and I spoke to 12 very large customers, finance, military, government, healthcare. I asked them all the same question. How many VLANs do you have? And the answer for 11 of them was hundreds. For the 12th one, they weren't sure if it was hundreds or thousands. So it's a very big problem, and it's a complexity issue. And I asked them, how are you managing it all? And the answer is spreadsheets. Oh, yeah, and some of you are shaking your head because you're doing the same thing, aren't you? Wouldn't it be great if we could take the complexity out of the network? Okay? You heard Brad Anderson this morning say in the keynote that on a daily basis, we make over 50,000 network configuration changes on Azure. You don't seriously think humans do that, do you? Any one of those could have catastrophic effects. We define policy. We let the network and the fabric do the right thing. We then push that policy into the fabric. We don't let humans actually make those changes. Finally, you can merge networks on the same fabric. So for example, if you've been part of a merger and an acquisition, okay, I've actually talked to a number of folks that have had this problem. Last year I spoke to a dairy here at TechEd. They had multiple different dairies that they'd actually merged with, and they had a whole bunch of different networks, and guess what? Lots of overlapping IPs, and they're trying to figure out how they're going to make this work, and guess what? Network virtualization all solves it. You can run all of the same IP addresses, same subnets, everything on the same physical fabric, and it's still logically segmented through network virtualization. So in 2012 R2, we're amping this up and taking it to the next level as well. One of the things we want to make it easier is to provide an in-box multi-tenant edge gateway. This is really important for cloud service providers because you want to be able to interface with a whole bunch of different customers that are taking advantage of network virtualization. With an in-box multi-tenant gateway, we provide that now in the box in Server 2012 R2. So with that, I actually want to get right on to the next demo. I'm going to invite Matt back up to talk about now virtual networking across clouds. And again, how do we manage that as well? Matt?
Thank you, sir. We manage it with Excel.
No, we don't manage it with Excel.
No, we don't. So again, back in Virtual Machine Manager. Virtual Machine Manager and Windows Server 2012 R2 with the Hyper-V component, they're both incredibly important parts to this software-defined networking story that we have. Hyper-V provides that engine, and VMM's really providing that management wrapper. And what we can see on top here, we've already defined a couple of what we'll call VM networks. These are our isolated boundaries, if you will. We've got one for the sales group, one for marketing. So in these cases, these could be groups within the same business, or as Jeff said, it could have come through an acquisition. It could be departments, whatever it may be. And in this case, the subnets don't overlap. So sales is on the 10.10, marketing is on the 172. But what if we did have another department that we needed to bring on board that would overlap? Well, with network virtualization, it's just not a problem. But let me show you how easy it is to start to create those VM networks, because it is a simple process to get started. So we'll create a VM network. We'll give it a name. So we'll call this one HR. And we'll define a logical network, so an abstraction of our physical network that this is going to sit on. So we'll choose our tenant provider IPs. We'll go next. And it's at this point that I define the level of isolation. So do I want to use network virtualization to isolate this from the sales, from the marketing, or do I not? They're my options at this point. I'm going to choose to isolate, and I could choose to use IPv4 within or IPv6. I'll go next. And it's at this point I specify my subnets. So this could be Jeff's department, HR in this case, come to me and said, yeah, all our servers, they run 10.10.
You don't want me working in HR.
10.10, hang on, that rings a bell. I think I've already got 10.10. Network virtualization means it's not a problem. So I'll create a HR subnet. I'll put it on the 10.10. There we go. And we'll go next. And this is the new bit. This is very important because, as Jeff said, this is how we start to now bridge that VM network and the HR servers that are in there with the external infrastructure, like the HR users' servers or desktops they have in the physical world, perhaps, or with any other servers that might reside in a service provider data center or in Azure. We need to be able to connect and punch through into that VM network if it's required. So it enables us to very easily do that with the in-box Windows Server 2012 R2, multi-tenanted, production-ready, scalable gateway. It will be marketed better than that way. It won't be like a really long product name. And we're going to turn on NAT as part of that, so that enables us to be a little bit more granular about how we control the addresses within that gateway, and we'll go next. I can tweak and tune NAT if I need to, but I'm going to leave it for now. And within just a few clicks, we've now created, through software, through VMM, a new VM network ready to host our HR servers in that environment. They'll fit into that subnet. They'll communicate seamlessly with one another. We don't need to re-IP address them, which is the beauty of it. And through the integration with the gateway, they'll communicate out to the rest of the world. But there's one important point. How do I get this gateway deployed? Well, as I said, it's part of Windows Server 2012 R2, but we don't want to just leave it at that. We want to help you accelerate how quickly you can deploy it. So if I go into my library in Virtual Machine Manager, and I bring up the service template that ships in box, and I open the designer, the service template designer, to give you a look at what this particular template looks like, we can see that it's a single VM template. It's got two NICs, so bridging those networks. And if I drill into the OS layer of this particular service template, and if you've not seen a service template, they help me to standardize and deploy services within my virtual environment quickly. You'll see that the OS config of this particular template defines the name, the consistent admin password, but more importantly, it turns on automatically the roles and features that are appropriate to provide the gateway services. Domain joined, the whole works. So I can very quickly and easily standardize deployments of new multi-tenanted gateways to support my increasing scaled virtual network infrastructure. With that,
awesome. Thank you, Matt. Wow. So again, think about what Matt has shown. We just did all of the logical provisioning of the network. We just deployed network virtualization. All of this through VMM with tight coordination and tight coordination with Windows Server. And one thing important to point out, I've been asked this every so often, Jeff, what do I need to do network virtualization? Is there something I need to buy to plug into Windows Server? No, you're thinking of the other guys. See, we built network virtualization into the platform. It's there. It's already there in 2012, and in 2012 R2, we're making it even better with the new multi-tenant gateway. System Center is the control plane. Windows Server is the data plane. So all of the management, the creation of those logical networks, my virtualized networks, all of that is happening from System Center, whereas Windows Server has all the network virtualization. It's just integrated and built right into our virtual switch. And again, now much better with the network gateway. In addition, we have a tremendous amount of momentum going on in terms of our networking partner ecosystem. We also have gateway appliances coming from F5, Iron Networks, and Huawei. One thing that's really important to point out is all of the things that we're doing are industry standard based. NVGRE is not a Microsoft proprietary thing. It's an industry standard. It's been around for quite a while. We're just taking advantage of it. So if you're using NVGRE, you know that there's no risk here. This is an industry standard. Arista is also building an OMI-based top-of-rack switch. What that means is through VMM, you're also going to be able to manage your physical switches as well, because OMI, again, industry standards based. We also have a bunch of folks plugging into our Hyper-V switch extensions. We've got Cisco, NEC, Five9, Inmon, and more on the way. But what's really cool is the flexibility you get. If you're a Cisco shop, the NEC, the Nexus 1000V is here. If you're an OpenFlow shop, guess what? The NEC OpenFlow switch ships only on Hyper-V. NEC actually looked at our architecture and said, this is perfect to drop in to create a plugin for OpenFlow, and that's exactly what they did. And that's publicly been available now for some time. Five9 provides security capabilities, and Inmon provides capturing of packets. So there's a wide variety of things you can do, as well as the ability to mix and match those different switch extensions in a Hyper-V because our flexible architecture. And then in terms of the chipset themselves, because we're using an industry standing NVGRE, guess what? All of the silicon vendors are plugging right into this as well. So you're going to see Broadcom, Intel, Mellanox, Emulex, Brocade, all doing native NVGR implementations in silicon. So there's this huge wave behind what we're doing in terms of software-defined networking. And again, there's a whole bunch more I can't talk about because they haven't announced yet. So there's a lot coming in this wave. Recovery services. So Replica has been extremely well received in the industry in 2012. And really, it's about making sure that we're providing lots of coverage for DR services. Even large enterprises that tell me, you know what, we already have a DR service in place, the first thing I always ask them is, great, are you happy with it? And usually there's a big, long pause. And I'm like, well, that answer tells me a lot right there. Well, why aren't you happy with it? Well, number one, it costs a lot. Number two, it has these really high-end synchronous big pipes requirements. And number three, because it costs so much, I'm only actually, covering a small fraction of my infrastructure. And I really, I'm only maybe, actually doing replication for, maybe 50 servers, where I'd like to be doing it for hundreds of servers. Well, that's fine. Keep that in place if you've got it. Replica is about broadening that coverage. So maybe you got 15, but now with Replica, let's go do the next few hundred. Because Hyper-V Replica is about making it easy, about making it simple, and about having low requirements and flexible requirements. Quite literally, it works with any storage. That actually is one of the key things about Replica a lot of people don't realize, is literally it just works with any storage. It can be direct attached storage in my machine, it could be a file server, it could be a SAN. But it's not tied to some high-end storage solution. It literally works with 2 servers with direct attached storage. It's one of the reasons why we're seeing people adopt it so quickly. In terms of Server 2012, customers love it. And in 2012, we told our service providers this is an awesome opportunity. What you should be, if you're a service provider, is be a target. So if I'm a service provider, I want Ben, for example, to replicate up to my cloud. Awesome. We had one little problem with this, though. Turns out the service provider said, we want to use replica too. So if he's replicating to me, that's all, as far as it goes. So we want to make this even better for cloud service providers. So in Server 2012, R2, we're including tertiary replication in the box. This means Ben can go replicate to me, and guess what? I'm the service provider, and I can replicate to another site. Oh, sweetness this is. All built right into 2012 R2. And then, of course, again, Hyper-V Recovery Manager. So Hyper-V Recovery Manager is built on the core request from you, which is, I want to be able to manage my replication at scale. And that means not only I got a whole bunch of VMs on site, but I've got multiple sites around the world. And the other thing is, we're very clear about this. Hyper-V Recovery Manager is the orchestration engine. None of the replication goes to Azure. That would actually be very inefficient. You want it to be point-to-point between your sites. We just orchestrate the replications between sites. That's exactly what we do. And of course, this has seamless integration with Hyper-V and clustering. So with that, I'd like to invite Michael Leeworthy on up to talk about some of the changes we've made in business continuity. Michael?
Awesome, thank you. So as Jess was saying, we've done some great things around business continuity, just really keeping virtual machines up and running, especially around singular virtual machines and also around sites, clouds, multiple virtual machines, whether they're 1, 10, 1,000, 100,000, it doesn't really matter with the new technology. So what I want to do is I want to walk you through a couple of demos to reiterate what Jeff was talking about and talk about some of the new cool things that we've built into some of these technologies around HVR and Hyper-V Recovery Manager. So the first thing I want to demonstrate, of course, is our online resize of VHDs. So the concept here is I've got a virtual hard drive. Let me go look at the settings of this. Oh, I'm running a little slow. Here we go. And basically, in this sense, I've got a SQL server, and I've deliberately made the volume of that SQL server quite small, so I'm running out of that. Now, if this was, a normal system, at this stage, I would have to think about how am I going to expand that, how am I going to resize that if I was in a fixed disk type environment. Basically now, while this is up and running, I can just simply resize it to the size that I want. Not only resize it, I can actually reduce it as well. So if I wanted to reclaim space from a fixed system, I could do this completely on the fly. So I can choose expand here. You can see that I've got 71 gig. I can make it 100 gig all the way up to 64 terabytes. I can click finish, and on the fly, that system is now completely resized. I can now go into that virtual machine and allocate that extra space to that volume and be able to utilize that volume. And the same thing as well. I can now shrink that on the fly as well. So this gives me that ability, again, to not take a workload offline when I want to do some configuration to it. Again, really trying to ensure that we get more extreme agility in my ever-running environment. The other thing we talked about was, of course, Hyper-V replication. And Hyper-V replication was fantastic in 2012, and we used it in our lab environments quite extensively to ensure that we can do backups in cross-site environments. Now, setting up replication is super simple. Setting up extended replication is just as simple as setting up the initial Hyper-V replication it was if you've looked at this technology before. So you can see here I've got another virtual machine that's completely running. I can enable that replication. And I'm going to go through the normal wizard. So if you've seen this before, the wizard is very similar in Windows Server 2008 R2 that it was with the 2012. But there's a couple of cool new steps which I think are really exciting. So I'm going to choose my destination as a server in my organization, or this could be a server and a service provider. It doesn't, at this stage, I'm just really connecting this by an internet connection or just through an Ethernet connection. I can use Kerberos, or I can use certificate-based authentication. Again, if I'm internally in my organization or I have domain credentials, I can use my Kerberos environment. But if I wanted to go to a service provider, I could utilize a certificate. And I'm also compressing that data over the network just to reduce that bandwidth need. What I've got here is a couple of VHDs. So I'm not going to replicate the page file here. I'm only going to replicate the system file. And you can see one of the new steps we have, as Jeff talked about, was the ability to choose the frequency of my replication. So before we used to have the single replication time. Now you can actually choose the frequency based on your needs. If you're in incredibly fast, if you're on a fast topology, if you've got fast Ethernet, say you're in a an organization environment where you just want to replicate from data center to data center across the road to different buildings, and you've got these high bandwidth links, then you can do near-time replication with Hyper-V replication at 30 seconds. If you've got low latency links, you can then move it out to 15 minutes if you're over satellite or low latency. The concept here is we're really providing you the flexibility of choice in the way you want to replicate, whether through fast bandwidth or lower latency bandwidths. You've got this now ability to replicate your asynchronous Hyper-V replica servers. So in this case, I'm going to do 30 seconds. I'm going to go through. I can configure my additional recovery points if I want, and I can choose my initial replication times. And this is one of the good things here is that, especially from a service provider perspective, maybe my initial replication could be quite large. So if I'm trying to replicate a number of virtual machines, these virtual machine VHD files and VHX files can actually be quite large. They can be 8, 12 gigabyte files, even to the terabyte files. And pushing them over like an internet link or a site-to-site VPN link up to my service provider could actually probably take days. What I can do in this environment, I can actually export this out to some sort of digital media. I can send it to them, courier it to them, drop them off on my way home. They can load this replica up in their environment, and then I can just basically sync up with the latest changes. So this gives me the ability to really define how I want to initially create the first replica of this. Now, since I'm doing this internally in my organization, I'm just going to do the initial copy over the network. And you can see here I can also define a replication time. If in your organization, since if I'm going to replica a bunch of servers, maybe I want to do it in the offline hours, I can completely configure that as well. And basically, at that stage, we're up and running. We'll have a replica immediately over to our Blue2 server. We are on a fairly fast network here. You can see that I have a replica of this virtual machine in an offline state, which is what you'd expect from an asynchronous replication. The good thing here now is I can take this replica and I can now extend that. So you can see here my replication, I now have a new extend replication feature. I can just click on this and it will walk me through a similar wizard where we had before, where I can now choose a extended replica server or this tertiary server, and now I can replicate the replica to that server. The great thing here is that you can see, from a choice perspective, I don't have the 30 seconds. Well, you don't really need the 30 seconds. I don't need all the information running around. The concept here is that I can do my initial replication over, say, 30 or 5 minutes, and then have this over the 5 or 15-minute component. This is great, as Jeff was talking about, from a service provider perspective. It gives you complete redundancy when you're trying to do replica from your initial site up to your service provider. It also provides that protection from your service provider in their own environment as well, in creating a sort of an offline copy of your environment for them. The last thing I wanted to show you is how we take this replica technology, as Jeff said, we sort of import it into a new technology we're bringing out in the R2 timeframe called the Recovery Manager. Now, our Recovery Manager is effectively built on my virtual machine environment. So you can see here I have two virtual machine manager environments. I have my current production environment, and then I have a disaster, or my disaster environment, well, probably not what I want to call it, my disaster recovery environment. So effectively, this is on-premise to me, and Jeff was making this point. I'm using Azure simply as an agent here. And this is really what I'm doing. Hyper-V Recovery Manager is effectively, I go in with my Azure account, I set up Hyper-V Recovery Manager, which is an add-on to my Azure subscription. I then download an agent, I deploy those agents on my VMM servers. I do a little bit about with subscription IDs to ensure that the Azure environment can talk to my VMM environment, and effectively I am done. I can then go and configure what I'm protecting. The big thing here is you're protecting from a cloud perspective, where before in Hyper-V Replica you're individually going in and protecting from an individual VM perspective. And yeah, you could go and protect 100, 500, 1,000 VMs, and you could orchestrate a site failover, but that's fairly custom for you. You would have to go in and write the orchestration for that, the PowerShell for that. You would have to deploy the PowerShell in a site recovery. You would have to manually run that site recovery process. This is taking all that concept and making it highly agile and highly easy for you. So you can see here is my recovery services within Azure, and I can go look at my Contoso Corp here. I can view my recovery environments. So you can see I'm supporting 13 virtual machines. I can go view those virtual machines, and I can go within the cloud and select which virtual machines within the cloud that I want to support, or I can just say, you know what, I want to support that entire cloud. So even if it's got 1,000 or 10,000 VMs in that cloud, I want to basically be able to support that entire cloud, and it would automatically do this within the Recovery Manager for me. I can do some basic configuration about how the replication is going to go through. You can see all this information has been pulled from my original agent, where it's the second VMM site where the replica is happening, what the target cloud is. But I can do things like replication start time, some replication timing information associated with that also. I think one of the big, amazing things that Hyper-V Recovery Manager allows me to do is have recovery plans. One of the hardest things in doing disaster recovery or site failover is the starting of VMs, the pre and the post jobs that I need to do. And you can basically now, with the Windows Azure agent, write recovery plans straight into my disaster recovery. So the concept here is that, out of the box, you can then define what's going to happen during each step of that failover. So you can see in a failover, I'm going to do some pre-failover steps. So if a failover happens, I maybe want to run some PowerShell on the destination environment to do some checks, to make sure that it's exactly how I want it to be, maybe ensure that I've got that baseline right. Now, once I've done that, I'm then going to fail over a number of these groups. So you can see here, when I do the failover, when I'm starting those virtual machines up, I want to start them up in a very specific order. Maybe I've got an online application or a web tier application. I need the database servers up. Maybe I need the middle tier up. I need the SQL server that supports the middle tier. Then I can go and support my web servers. I'll bring up the web servers once my SQL database tier and app tiers, and so on. And I can actually define as many of these as I want. And then you can see I can do some post-failover steps as well. There's a number of other things that I can do as well. I can add, add things such as PowerShell scripts in here and run those PowerShell scripts. Effectively, I write a PowerShell script, I store it up in a shared environment, and that PowerShell script will run in that environment, within that steps. I can also do a manual action here. And the idea here is that maybe something needs to happen. If I do a failover, my lab guy needs to go and do something. He needs to, Jeff had a great point, he needs to go and ensure there's diesel in the generator, or, or something like that. There's a manual action that needs to be done, and before the failover is marked complete, I need this to be done. Maybe something needs to happen at a switch level. Maybe something needs to happen at a data level where I need somebody to physically go and do something. The great thing about this is that it will hold this, it will provide a message. I'll have to go in and do that step, and then I can come back, I clear the message, and the failover will continue. So you can see here that Hyper-V Recovery Manager really provides me that ease of agility, utilizing great technologies built into Windows Server and Hyper-V Recovery Manager, and all the new advances we've built into Windows Server 2000 R2, and also, of course, System Center 2000 R2. Thank you.
Awesome. Thank you so very much. So you can see we've shown a variety of different things, and again, we've had very little time, and there's a whole bunch of new things in 2012 R2. Think about some of the things. I want you to make sure, if you're interested in storage, we have a lot of storage conversations. We've only touched on a number of things, tiering and deduplication, but there's a whole bunch of new enhancements around SMB, the scale-out file server. We're going to go in depth on that this week. The networking stack. Didn't get a chance to go too deep into the extensible switch, as well as changes that are happening in terms of NIC teaming and things like that. So there's changes happening there. If you're interested in PowerShell and automation, we've got some major new advancements in PowerShell you're going to want to hear about. Of course, PowerShell is something we use just it's like drinking water now. It's something we use just everywhere within Microsoft. All those demos you saw doing in the keynote, for example, those very much PowerShell is underpinning all the automation that we're doing below hand. So there's a tremendous amount of work going on there. Just a reminder, a couple things. Number one, Microsoft workloads absolutely run best on Hyper-V. It's the most tested platform. Like I mentioned earlier, on a daily basis, in the server division alone, we test at a minimum 25,000 VMs a day, and on average over 500,000 a month. That's just the server platform. I'm not even talking about Exchange, SQL, and the other guys. It's part of our common engineering criteria. Every new product, every new technology is supporting Hyper-V by default. We integrate within our teams. So for example, Active Directory in Server 2012 now supports the ability to deploy domain controllers as virtual machines. Now, anybody who's been a domain controller, an AD domain admin knows you'd never do that in a million years. Well, you will with Hyper-V because we've actually provided the technology to make it work. We've also done that with BitLockering and clustering and encrypted shared storage, as well as automatic VM activation as a new feature that, again, something you're only going to find in Hyper-V because we test, we integrate on our own platform. Dynamics, Exchange, SharePoint, Link, SQL, Windows, Azure is 100% Hyper-V for compute. I cannot say this loudly enough. Windows Azure, our global cloud, runs on Windows Server 2012. Okay? It is Windows Server, and it is the best supported platform. So it's time, folks. It's time to virtualize every workload. It's time to rethink storage. It's time to simplify network, to expand business continuity, and deliver hybrid services, and to ensure application availability. Thank you so much. I hope you have a wonderful time here at TechEd. We'll be here on the show floor where we have lots of demos. We have lots more sessions throughout the week. Hope you enjoy the rest of TechEd. Thank you very much.